Alright, I hope you can hear me. None of my code is commented, and I've got 5 minutes because I got the free version. I hope you can hear me. None of this is commented, and I've got 5 minutes because it's the free version of the program, so I'm just going to try to take you through so we know what's going on. I'm doing a bunch of importing here. These are a bunch of integers. These are the integers I use to store the date ranges which I want to keep. I know there's a better version way to do it, but I'm out of time. Here in this string is the words I want to, or in this array is the words I want to look for in the text. Here's just the buffered reader stuff, and then it sends it to the trimmer. The trimmer is in sentence one. Basically, is going over here. I know it's super messy. I hate the way I did it, but I'm out of time. um, Basically, the way I figured out a better way to do this later, but I was just getting back into the swing of things with Java. Basically, if it sees a quote, which I've got a quote, which is a literal quote, or like a comma. I've got a string of a comma or a quote here, and if it sees that, osint.length, or sorry, yeah, char at 0. If it sees that, then it'll add one to the even odd calculator, and then it'll add a delay function, which basically just makes it work properly. And if there's an odd number of quotes, then we know we're inside a quote. If there's an even number of quotes, then we're outside of a quote. And then it looks for commas in the same way. I've got to keep moving because I need to keep moving because I'm almost out of time. This is basically just more cleaning up. This is more cleaning up the way I dealt with the months. I know there's a better way, but still getting to swing things with Java. So basically, it just looks for it looks for a 0, and then it looks for a 0 or a 1 in the first character slot, and then it looks for a number in the second character slot. And up here we had them all declared. And the same way, if it finds both of them, then it says, okay, that's September, that's October, and it just defines month F as month F plus October, and month F is just an empty string. If something fails, it just returns fail. I remember try catch loops way too late, so a lot of this stuff here is, or a lot of random stuff here you'll see is because I didn't have a try catch loop in at the time, but I remembered. And then it returns rarity, which is just it's the final year, the final day, the month, author, text, and then month Z, which is just the month in um, just a number format because it was easier to deal with that way. So moving down, oh shoot, no, we were way up here. Yeah. Okay. So equal to center one trimmer.data. Yeah. So we were here. So now we have an array called datas, and then basically I had this is just here because I didn't know try catch loops, or I didn't remember them at the time. I figured them out later, but it just basically checks to see if it's the right thing in a certain character slot, and if it's not, it's likely an error. So it just ignores those. But if it's not in error, then it keeps going. Strings. So this array is filled with the splitter from data 4. Data 4 is says in data 4. Oh, data 4 is just it's just the fourth data in string format, and then it sends that into sent1 again. We are looking for a splitter. Yep, they just words.split. I remember better ways to do things. It returns it back, and then if there's an exception, it just returns a fail. So coming back here, if I'm gonna have to put it in two parts. I did this a couple days ago. If words.contains key. Oh, this is the hash map stuff. Basically, it just puts it all in the hash map. I didn't end up using the hash map, but I still made it just to remember, just to make sure I could. Basically, if it's not in the hash map, it puts it in the hash map with a code of 0, and then it looks for it in the hash map, and then if it's in the hash map, then it adds 1 to it, so we can get a nice count of what all of those common words. Didn't end up using it, didn't end up needing it, but it's cool to have. The big one. The big one is our array list, and Yeah, we're still in this. We're still up here. So the big one is just my big array list of the whole data. Oh. So the big one is just our big array list of yeah, it's just the whole everything from sentence splitter, and all the data coming back is just now formed put into the big one. Because data is equal to the sentence trimmer stuff and then data. So yeah, the big one is basically all the data coming out of the word processing, and then num equals 1 to plus 1. We're just, yeah, I was counting the amount of times it went so I could then print it out because I was seeing errors. So now we come down to the next part of it, which is let's just read real quick. Yeah, so this is just the sentiment analysis part. Here's a bunch of variables I used for various reasons. There's this big long if statement. Basically, yeah, big long if statements to say, okay, yeah, okay. So this is the big part. This is the super important part. Basically, if these words are in, it goes through the array, which it basically goes through the sent array, which is just temp sentence dot split, and temp sentence dot split is temp sentence is equal to temp4, and temp4 is basically the message or the main tweet body from the Twitter. And then this is why I'm recording it for you because my coding's a mess, and if I was rushing, I'd do better. But so basically, it splits it back up into words and creates an array out of it, and then for the length of array, it basically goes through each member of the array and then and looks for search words. This is an array of 3, which is search words. Search words, because all the way back up here is basically we're looking for protests, protesters, basically a couple variations to make sure that catching all, if I'm trying to report on protesters, if I only look for protests, it's not going to help if someone says, blah, 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 these protesters. So we catch all of them, and then, so if those exist, and I'd like to put, yeah, it also makes it run a lot faster to check for these words first. Basically, if the start year and int year, so int year is equal to parse int temp year, integer.parseInt temp year. So basically, temp0 is equal to the year, and so temp year is just, we set it equal to a string, and then we set it to an integer here, and then we do that for temp year, temp month, temp day. So it's just of that tweet, this is the year, month, day. So if int year is equal to the start year, or is greater than the start year, and it's less than the middle year, and month is greater than the start month, less than the middle month, day is greater than the start day, less than the middle day. These start day is basically when you want to start looking for tweets. Middle day is your cutoff day, so if an event happens on a day, that's going to be your middle day, and so you're going to stop looking then for some sections, or start looking then to basically the before and after, and the end dates are the end dates. You get it, you're smart. I don't need to. Anyway. So basically, if it's between the start date, if the timestamp for the tweet is in between the start date and the middle date, it'll number.get sentiment. I set up a whole bunch of things in here. Didn't end up using them because I ended up doing it in a different way. Basically, I ended up putting all this out here instead of passing all the information through. So this is the sentiment analysis through, basically just the Java SQL or whatever, or the Stanford, Core NLP. And so it does the sentiment analysis, and then we come back out here and it spits it out for each individual tweet. So number is the sentence So number is going to be it's just the number it spits back out. And then here's just some print statements so I know what's going on. It's how I code. And then total number. Okay, back at it again. I'm trying not to waste your time. I'm trying not to waste your time. Hopefully you don't need to see this. I ran out of time on that 5-minute trial. Anyway, back in it. Yeah, just printing out statements, see what's going on. Total number equals total number plus 1. This is how I know how many times, or basically how many tweets included those numbers. And then that's the times activated. And then the total number is basically the total sentiment number of all of the sentiment tweets. That doesn't make sense, but basically if it has sentiment of 1 and then a 2, it adds them together and then you have 3. The purpose of this is so that you can then get the mean pretty much. So the big one, stats, is basically it's the big array of stats. It's the big array of just all of the numbers that get spat back out by the sentiment analysis added up. Or no, not added up, but in their own slots. I then do it again, but this is just for after the date. I have to change it a little bit because technically this if statement is a little bit faulty, but it doesn't matter because it ended up working out with my dates, but it was faulty, and so I fixed it for this one, and I'd fix it for that one if I had more time. So basically same thing, but after the dates, and then more print statements so I know what's going on. After this, for average sentiment, yeah, basically, for average sentiment was blank. After the average sentiment was blank, the total stats, the total number of sentiment reported divided by the number of times it's activated to get the mean. So now I need to get the what's it called? The standard deviation. So, and I'm gonna do the rest of the calculation by hand, but getting the standard deviation is nice, so it's automatically reported no matter what. So, as big as the big array of stats, it just goes through it every time. Number 3 is equal to, it's just a temporary number I'm using. I know it's bad, that's why I'm recording this. Is equal to, that particular stat minus the mean of the total stats times the same thing, which is it's just the standard deviation formula. And then you add them all together to get the sum of the square root of the sample, or the individual thing minus the mean. I'm tired. But you do that twice to get the, and then yeah, you get that, and then with that number, with the sum of the whatevers, you divide it by the number of times activated minus 1, and then you square root that, and that's how you get the standard deviation. And we get the standard deviation before and after. Final little thing is because I like things to be nice and organized, is that I just basically it creates a text document, and then it writes in the text document the mean times, the number of times it was the mean sentiment, the number of times that the terms were referenced in tweets over that time span, and then the standard deviation for that time span, and it spits it out nicely into. Oh, this little thing is in my way. I can't see. Am I goated? Yo, okay. I actually couldn't see what I was typing because the screen recording UI is overlaid over top my command prompts. But we got there. It should run pretty fast because I'm excluding all the data that didn't include the words I was looking for. This code can do a whole lot, but this is just, it's got a lot of vestigial abilities, but this is basically what I found was useful. So it creates a text document. Oh my god, my voice is dry. It's just called output.txt. I'm going to put it up here for you. Oop. Yeah, I'm just going to open it up for you. It just basically writes and creates this text document. So here you can see all the beautiful data, and yeah, you'll see the rest of my report of what I'm doing with it, but awesome. This was a lot of fun. I wish I wasn't. I'm just, whatever. I've got no excuse. But we got there. I'll see you around. Bye bye.